We're excited to share a solution that we've built for containerization technology for targeted specifically at embedded devices that run Linux, usually on the low end, less than 2 gigabytes of RAM, all the way down into devices that are running Zephyr or other RTOSs. Docker is the industry standard for containerization, but it doesn't support devices at this level for a number of reasons. And we're really excited to have built a new piece of technology that allows for the benefits of containerization, but also the management of those containers once they're out in the field on a fleet of devices. So how have we done this? We're leveraging a technology called WebAssembly. WebAssembly is a technology that was developed about 10 years ago to deliver on the promise of Java. Java was intended to be write once, run anywhere, but you had to write in Java. And WebAssembly really allows you to do that in any language, but it defines its own bytecode. It requires a small VM to run, and we've developed a runtime for this set of devices that we have running from Linux all the way down to the RTOS side that is very, very tiny and allows you to run WebAssembly modules and manage them the same you might as a Docker container on a server, for example. So our runtime is, as I mentioned, very tiny. On Linux, it's about 5 megabytes, statically linked. And then down on the embedded side with an RTOS, we can fit in devices as small as 256 kilobytes of flash and RAM. And we're super excited about what this brings with security, with updatability, allowing people to be able to not have to restart a device that's out in the field and functioning. Maybe they can just update a single piece of that device. It could just be the web server, it could be the sensor interface, it could be the ML model that's running at the edge. We see a lot of applications in the edge AI space, especially today, where models need to be continuously deployed. You're getting data back, you're retraining that model, and you need to push that back out to the field in order to continuously deliver value to your customers. But that's really difficult to do with a traditional embedded firmware approach. Also, those models may or may not be developed by a team of people who are embedded designers, and they may or may not be developed in a language that would run on an embedded device like C or C++. So our containerization solution allows you to write in a language of your choice, meet your developers where they're at, and use a modern workflow for getting those containers down to a device. One of the really cool things about our platform as well is we're driving for a standard in embedded containerization. Our runtime that runs on these devices is actually open source. It's called Ocre, O-C-R-E. You can look it up on GitHub, and we've contributed that to the Linux Foundation because, as I said, we want to drive a standard for embedded containerization. What we do as Atym is we build a layer on top of that for managing and orchestrating those containers once they're out in the field. If you want to get started, our runtime is open source on GitHub, as I mentioned, but also we have a developer program. If you go to our website, atym.io, it's a great way to get started, see what our toolchain looks like, and learn how you can deploy containers to embedded devices.